Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math, Module 4, Lesson 1, the relationship between addition and subtraction. It's hard to believe that we're already to Module 4. Can you believe it as I move this around even while I'm recording? Today, and even going forward into Module 4, the entire module has a lot of what we call expressions and equations. And a lot of that involves addition, subtraction, and then we'll get into multiplication and division. Now, when you see addition and subtraction, you may be thinking, well, that's kind of easy stuff. You know, I know addition and subtraction. It's not just adding and subtracting, but it's being able to look at expressions and equations that use variables. It's looking at relationships. And so a lot of these first videos will be, I think, fairly short. So I don't want you to feel like we're going to spend a ton of time talking about addition, things that you may or hopefully already know. But we're going to be focusing on what we need to look at to move forward in addition and move forward in subtraction, and to improve on that, the basic skills that we have, but also to learn new skills. So please don't think it's old stuff, it's new stuff. Let's go ahead and get started. Okay, let's look at a little bit of addition here. Addition and subtraction. So let's say I asked you to represent the number 10 with a tape diagram. You might create something like this. Tape diagram with 10 individual spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got it. Now, if I asked you to remove 6 squares or 6 sections of the tape diagram and write an expression to represent that problem, or that part of the problem, what would you write? Well, first of all, you might take away 6 squares, right? There's 1, 2, 3, 4, 5, get that as close to accurate as possible. 6, okay? So the expression, and this is a vocabulary word, the expression does not have an answer. So the expression of what we just did would look something like this. We have 10 minus 6. Notice it does not say equals 4, because that's the equation. I just want the expression. The expression just shows the math that we just did, right? So 10 minus 6. Now, if we were going to add 6 squares back on, then visually it would look like this, right? 1, 2, 3, 4, 5, 6, something like that. And let's change the expression to represent the current tape diagram. So we did 10 minus 6, and then we added 6. 10 minus 6 plus 6. This is our expression. It's an expression because it doesn't have an equal sign. It's just the math without our final answer. Now, if I asked you, or if you were asked to evaluate the expression, I know that sounds fancy, but all it means is answer it, right? Solve it. Give us the answer. So 10 minus 6 plus 6. Well, first of all, if you just went left to right, you could say 10 minus 6 is 4, plus 6 is 10, and you would have your answer as 10. You could also look at it as, wait, I have a minus 6 and I have a plus 6. Those two are going to cancel out, so I just have 10. So if you evaluated the answer, you would get 10. Let's use this expression to talk about variables. Variables represent a number. They are letters, oftentimes X or Y, but they could be other letters, and they are in the place of a number. So if I said, just for example, 2 plus X equals 4, X isn't anything fancy. X just means there should be a number there. We don't know what it is, so X represents the number. In this case, we'd say 2 plus what equals 4, and we know, well, 2 plus 2 equals 4. So in that example, X equals 2, because X is 2. It just wasn't written in that way, right? So if I asked you to then go back and look at the problem that we just solved, 10 minus 6 plus 6, that expression, could you write an equation using variables to represent the identities we demonstrated with the tape diagrams. The problem that we just did, right? Oops, sorry. The problem that we just did. So we ended up with 10 minus 6 plus 6 equals 10. So if we wanted to say we're going to use W in the place of 10, we could have W minus, and then let's say we wanted to use G. Why not? G in the place of 6. W minus G plus, well, here we have another 6, and we've already established that G is 6. So plus G equals, and then our answer to the equation was 10. We've already said that 10 is W, so we put W again, right? W minus G plus G equals W. And what this expression, or what this equation I should say, is actually demonstrating is that two things. One, if you have an opposite value, such as negative G or minus G, and its opposite, you have two opposites, they're going to cancel each other out. So basically you end up with W equals W. The other thing that this kind of expresses is that if you have a value and you take away a number from that value, and then you add back in the same number, you're going to end with the original value. So we've talked about variables, we've talked about expressions. Now let's use this rule, W minus G plus G equals W rule, to solve a couple of problems. Okay, let's start simple. We have 4 plus 5 minus something equals 4. Now I could have put an X here, or a variable there. It's the same difference as having a blank space. It just means there's a number there, we don't know what it is. Well, if we're starting with 4, and then we're adding 5, and then we're taking something away, and we're ending with 4, the answer here has to be 5, right? We have 4, we add 5, we take away 5, and we're back to 4. So our answer in this case was 5. 25, take away something, add 10, gives you 25. We're starting with 25, we're ending with 25. We're adding a number, and then, or excuse me, we're taking away a number and then adding 10, but we end up with the same thing here. So these two have to cancel out in the middle. So we're taking away 10, and then we're adding 10 to give us 25, right? It makes sense. The overall change to the expression is 0. It doesn't change anything. We started with 25, we ended with 25. If you subtract a number and then add the same number, you didn't change the expression. If you lose $2 on the ground and then find $2 down the street, guess what? The change to the money you have is 0. You don't have more or less, you have the same that you started with. If we have, now we're into the variables, right? If we have A and we end with A, but in the meantime we added B and then took something away, these two have to be opposites, right? Because we start with A and we end with A. So then if you have A and then you add B and then take away B, you're back to A, right? So plus B minus B basically cancel each other out. So you have A still equal to A. C minus D plus D equals what? Well, hey, here you go. You have a number C. You take away D, but then you add the D back in, you're going to be right back to C. And then finally, we start with a number, we don't know what it is. We take away H, then we add H back in, so those basically cancel out, and we end up with G. That means we must have had G in the first place. Okay, so I hope you kind of see the pattern there. We'll talk a little bit more about this in class. Thanks for watching, and we'll see you then.